OS Basics. Bootstrap process. In computing, a bootstrap loader is the first piece of code that runs when a machine starts and is responsible for loading the rest of the operating system. In modern computers, it is stored in a ROM, but I recall the bootstrap process on the PDP-11, where you would poke bits via the front panel switches to load a particular disk segment into memory and then run it. Needless to say, the bootstrap loader is normally pretty small. Bootstrapping is also used as a term for building a system using itself, or more correctly, a predecessor version. For example, ANTLR version 3 is written using a parser developed in ANTLR version 2. This diagram shows how the bootstrap process works. Bootstrap process involves first, performing a power on self-test post. Second, locating and initializing peripheral devices. Third, loading the bootloader, which transfers control to the operating system. Bootloader. Bootloader is a piece of code that runs before any operating system is running. Bootloaders are used to boot other operating systems. Usually, each operating system has a set of bootloaders specific for it. Bootloaders usually contain several ways to boot the OS kernel and also contain commands for debugging and/or modifying the kernel environment. Since it is usually the first software to run after power up or reset, it is highly processor and board specific. It is saved in master boot record (MBR) of the storage devices, which is a space constraint. It is about nearly 446 bytes. Example: GRUB, Berg, SysLinux, and TLDR. This is the screenshot of GRUB. GRUB stands for Grand Unified Bootloader. This is the screenshot of SysLinux, example of bootloader. This is the screenshot of Berg. Berg is a brand new bootloader based on GRUB. Now let's go to the operating system. An operating system is a collection of software that manages computer hardware resources and provides common services for computer programs. The operating system is an essential component of the system software in a computer system. Application programs usually require an operating system to function. Example of operating system: Unix and Unix-like operating system. Second, Linux and GNU. Advantages of the operating system: first, for the end user, help to get things done quickly. Second, for the application programmer, use programming language and call library routines without caring about hardware level details. Third, for the system programmer, create abstractions for the application programmers as well as deal with real devices. Types of operating system. First, real-time. It is a multitasking operating system that aims at executing real-time applications. Second, multi-user. It allows multi-user to access a computer system at the same time. Third, multitasking versus single-tasking. It allows more than one program to be running at the same time from the point of view of human time skills. Fourth, distributed. A distributed operating system manages a group of independent computers and makes them appear to be a single computer. Fifth, embedded. Embedded operating systems are designed to be used in embedded computer systems. Components of operating system. First, kernel. In this kernel, there are many parts: program execution, interrupts, modes, memory management, virtual memory, multitasking, disk access and file systems, device drivers. Second, networking. Third, security. Fourth, user interface. There are basically two interfaces: graphical user interfaces and command line interfaces. Kernel. The kernel acts as the interface between applications and the actual hardware. Modes. Modern CPUs support multiple modes of operation. CPU with this capability use at least two modes: protective mode and supervisor mode. Virtual memory. The use of virtual memory addressing means that the kernel can choose what memory each program may use at any given time, allowing the operating system to use the same memory locations for the same multiple tasks. Networking. Computers running dissimilar operating system can participate in a common network for sharing resources such as computing files, printers, and scanners using either wired or wireless connections. Networks can essentially allow a computer's operating system to access the resources of a remote computer to support the same functions as it could if those resources were connected directly to the local computer. This includes everything from the single communications to using network file systems or even sharing another computer's graphics or sound hardware. Some network services allow the resources of a computer to be accessed transparently, such as SSH, which allows network user direct access to computer's command line interface. Security. A computer being secure depends on a number of technologies working properly. A modern operating system provides access to a number of resources which are available to software running on the system and to external devices like networks via the kernel. User interfaces. Each operating system has a user interface, a program that accepts requests from users and interprets them for the rest of the operating system. A user interface in some operating systems such as Unix is called a shell. In others, it is called a window to denote that it is a menu driven and has a GUI component or CLI. Graphical user interface. GUI accept input via devices such as computer keyboard and mouse and provide articulated graphical output on the computer monitor. There are at least two different principles widely used in GUI design: object-oriented user interfaces and application-oriented interfaces. Command line interface, where the user provides the input by typing a command string with the computer keyboard and the system provides output by printing text on the computer monitor, used by programmers and system administrators in engineering and scientific environments and by technically advanced personal computer users.